Good morning, student. Let's start today's class. Today we will study about transmission impairment. Okay. In previous classes we have already discussed about analog transmission and digital transmission. Now now we'll see the the problem which we faced to transmit uh, the data, the digital data or analog data in a transmission medium, that is transmission impairment. Okay, signal travel signal travel through transmission media which are not perfect. The imperfection caused signal impairment. Okay, this means that the signal at a beginning of the medium is not the same as the signal at the end of the medium. Okay, what is sent is not what is received. Three causes of impairment are attenuation, distortion, and noise. Okay, that means when we send a data through transmission medium, our transmission medium is not an ideal transmission medium. Okay, there is so many errors, noise, and so many things which changes our sending data, and we receive the data which we send differently. That means what we send and what we receive are different. Some losses or some addition are there. Okay, so that imperfection of the uh, transmission media is called transmission impairment. Okay, and this transmission impairment is or caused due to three things. What? Attenuation, distortion, and noise. Okay, now let us see what is attenuation. Okay, attenuation means a loss of energy when a signal, simple or composite, travel through a medium. It loses some of its energy in overcoming the resistance of the medium. That is why a wire carrying electric signal gets warm, if not hot, after a while. Okay, some of the electrical energy in the signal is converted to heat. To compensate for this loss, amplifiers are used to amplify the signal. Here, attenuation means the sum of energy were lost when we transmit the signal through a when we transmit the message signal through a transmission medium. That means when we send a single a single signal, simple or composite. Composite means combination of two or three or more than two signals or informations by superimposing or multiplexing or something else. Okay, that is called composite signal. Travel through a medium, it lost some of its energy because in a medium, in wire medium, let's say wire medium, there is some resistance of the wire. Okay, there is some uh, there is so many of resistance or resistive force, that due to which our sending message signal lost some energy. Okay, in for example, if in sending or in electric wire, when electrical signal is transmitted or travel, there is a heat, there is some heat produced in the wire. Okay, that heat is due to the energy loss uh, by the energy loss due to the resistance of that wire. Okay, here see, this is original signal. Okay, point A रे, point 1 ले, and this is transmission medium. Okay, after after going through transmission medium, uh, the original signal lost some energy, and here the attenuated means the losses energy. After losing energy, this is our signal, this is our data in point B. After we use amplifier to overcome these energy losses. So here we use a amplifier. Okay, amplifier, we amplify the energy of the attenuated signal. Okay, and get the original signal. Okay, in point 2 feed to the amplifier, and it amplifies, and we get amplified signal in point 3. Okay, point 3 we get amplified signal of the original signal. Okay, then we discuss, then we what is decibel. Okay, you know, decibel is the intensity of the sound. Decibel is a unit of intensity of the sound. Here, to show that a signal has lost or gained strength, engineers use the unit of decibel. As like as to show the intensity of sound, we use decibel unit. Here also, to see the signal has lost or gained the strength, we use the unit decibel. Okay, decibel is denoted by dB. Okay, measure the relative strength of two signals or one signal at two different points. Okay, decibel measures the signal in 2 points. That means here decibel measure the strength in point 1 and the strength of the signal in point 2, and compare it and get a result that the signal lost or gain strength. Okay, note that the decibel is negative if a signal is attenuated. That means if signal lost some energy, then the decibel is negative. Okay, and positive if a signal is amplified. If the signal is amplified, that then the uh, amplifier means gain some energy, then the decibel is positive. This is the formula. Okay, this is the formula of what, that is what decibel. Okay, 10 log p2 means point 2 divided by point 1. Okay, point 2 divided by point 1 means here p2, variable p1 and p2 are the powers of a signal at point 1 and point 2 respectively. That means okay, this this point power p2 and this point power p1. That means at that point p2, the what is the power of the signal is p2. Okay, at the point of p1, what is the power of signal is p1. Okay, so remember this formula, 10 log 10 p2 and by p1. Okay, p2 is the power at point p, that is point p2 is the power of signal at point 2, and P1 is the power of signal at point 1. Point 2 means this is the output side. Okay, output side, this is in the input side. That means a signal, the power P2 means the power of signal at output side. Okay, and the P1 is the power of signal at input side. Okay, ଏମିତି ଗୋଟେ ଏମିତି ତୁମର ଯଦି ପଡ଼େ କ୍ୱେଶ୍ଚନ୍ ଏକ୍ଜାମ୍ପଲ୍ ତୁମେ ଦେଖିନ ହେଲା କେମିତି ହେଇଛି ସେଇ ଫର୍ମୁଲା ବେସ୍ କରିକି ଓକେ then we see what is distortion. Okay, distortion means that the signal changes its form or shape. Distortion can occur in a composite signal made of different frequencies. Okay, each signal component has its own propagation speed through a medium and therefore its own delay in arriving at the final destination. Difference in delay may create a difference in phase if the delay is not exactly the same as the period duration. Okay, in other words, signal component at the receiver has phases difference from what they had they had at the sender. The shape of the composite signal is therefore not the same. Okay, distortion means the changes in the shape of the sending signal at the receiver end. Okay, when we if we send this signal in sender, we in receiver end we get this signal. Okay, this is phase shift of 180 degree. Previously we told I told you that this is shifting of phase. This is phase shift of 180 degree. So the phase or the shape of the sending and receiving signal are not same. This is called distortion. Okay, and this phase shift happened due to the and this distortion is occurring especially in composite signal. Composite signal, there are many signals combined, or there are many signal having different frequencies combine each other. Okay, means one signal, this signal, and one signal, this signal, and one signal, this signal. These three signal have different frequency. Okay, and when these three signal combined and get a signal like that, this is called composite signal. Okay, and this due to composite signal have different frequency, it reaches the uh, receiver end, or the component of that composite signal reaches the receiver end in different times. Okay, and the delay occurring delay occurring in reaching that composite signal at receiver end is different. Okay, and that due to the delay the phase shift happened. Okay, the phase shift in the composite signal happened. Okay, this phase shift here. See, this is one composite signal at the sender end. Okay, this is the composite signal at the receiver end. Okay, there is, you see, there is a distortion here, you see, and here you see there is a distortion. Okay, and this is the different frequencies signal combined. Okay, and you see the phase shift here, the phase shift here, the phase shift. Okay, compare it here, the phase shift. Okay, next we see what is noise. Okay, noise is another cause of impairment. Several types of noise such as thermal noise, okay, thermal noise, induced noise, crosstalk, and impulse noise may occur in signal. Thermal noise is the random motion of the electron in the wire which treat at extra signal, not original sent by transmit. What is thermal noise? That means in a wire the producing of heat which happened due to the random transmission of electron inside the wire is called thermal noise, because the random motion of the electron, due to the random motion of the electron, some thermal generated, that thermal is called thermal noise, which is gained or which is added to the sending signal. Okay, sended signal. Okay, then induced noise come from source such as motors and appliances. Induced noise is the noise which produced at the sender side due to using motors or any other appliances. There is a spark inside our motors, okay, and other appliances there is spark or electromagnetic radiation which interfere our signal with the signal or in signal. They, the, that noise produced in the or induced in the transmitter side, and that noise is called induced noise. Okay, here transmitted and noise transmission medium created, and receiver and the transmitter signal is changed. Okay, to find theoretical bitrate limit we need to know the ratio of the signal power to the noise power. The signal to noise ratio is defined as signal to that means we uh, that means to measure the noise. Okay, then to measure the portion of noise added to our signal we use a term or we use a unit not parameter to measure the noise added to our signal, that is signal to noise ratio. That means the ratio between the signal and the noise, okay, which is called SNR, average signal power divided by average noise power. Okay. And because SNR is the ratio of two power, it is often described in decibel unit. This is also described in decibel unit. SNR dB defined as SNR dB equal to 10 log SNR. SNR, SNR, what is SNR? The ratio of average signal power and the ratio and the average noise power. Okay, and SNR dB equal to 10 log 10 SNR. Okay, okay, thank you.